Hello and welcome to lecture number 2 on algebra of functions. So what are we covering in this lecture? We're going to be doing some algebra with various functions. What does it mean to do some algebra? Well, let's go back to numbers. Let's see the analogy between functions and numbers. When you have two numbers, I'm going to take 2 and 3 for example. How can you do some algebra with them? Well, you can add them, and that's 5. You can also subtract them, and this is -1. You can multiply them, this is 6, and you can divide them. And let's write that as 0.6 repeating. Well, these are the 4 algebraic operations you know with numbers. We're going to do exactly the same with functions. You're going to be given two functions, f and g, and we're going to combine them to create a new function. See, when you take two numbers and you do some algebra with them, you have another number. So what are we going to do? We're going to add them, we are going to subtract them, multiply them, and divide them. So let's write it like that. There is also a fifth operation that does not have an analogy with number. It's called composition of function. This is not red fog, okay? It's f composed with g. This is an operation that does not have an analogy with numbers, okay? So let's start with the first 4 operations. How can you define the sum of two functions? So actually, go here. If you're taking two functions, how can you define the sum of two functions? You have to realize that this plus written here is not the plus that you're familiar with. Why? Because this is a sum of functions. I have no idea what that means. I know this plus there. I know this one. That's a sum of two numbers. I know what that means, but the sum of two functions, I don't know what it means. So to define a new function, well, you can just express what it does to an input, right? And give the expression for it. So what does this function, how can we define the sum of two functions? It's very straightforward. Just add the outputs of both functions, f of x plus g of x. Now this plus right here, I know this one. This is something I don't know. This is something I know. Why? Because this is a real number, right? This f of x right here, it's a real number. It's the output of a function. This is a real number. So what are you adding? You're adding real numbers. This is a sum of two real numbers. Okay? So this is how we define the sum of two functions. How do we define the difference, the product, and the ratio? In the same way. What do I mean by that? Let's, for example, look at the ratio. Right here, I'm dividing two functions. I have no idea what this symbol means. Okay? So to define this, because it's a function, let me tell you what it does to an input. Well, it's very simple. You take both outputs and you take their ratios. Okay? The ratio of the outputs. Let's go over some examples. Here we go. I tend to forget my S's when I record. I've noticed that. Let's insert some space here. Okay. All right. So here are two functions, f of x and g of x, and I'm supposed to find the sum, difference, product, and ratio. Okay, let's start with the sum. So here again, let's write the definition. By definition, this function is the sum of the outputs, and from then, let's just add the outputs. So you take the expression of f, you take the expression of g, and you just combine them, right? So this is 2x squared. Negative x minus x is negative 2x, and negative 6 plus 2 is negative 4. We could factor 2. We don't have to. This is not the question. Let's do now the difference. So again, I always write the definition, okay? Just to make sure I know what I'm doing, and I advise you to do the same thing. if your answer is wrong, at least you're going to get some points because you're showing me that you know the definition. So f of x minus g of x, what it is? It's 2x squared minus x minus 6. This is f of x minus g of x, 2 minus x. Now, this is wrong. You have to be careful here. You should put the parenthesis around g of x. You got a negative sign in front, right? I should actually, in the first one, normally I should put the parenthesis here, but come on, it's a plus, it doesn't matter. So, what is this? Well, let's simplify. Don't go too fast if you're not sure. Minus 6 minus 2 plus x, right? So what do we have? We have negative, no, just 2x squared. And then the x's, they cancel. Negative 6 minus 2 is negative 8. Here again, we could factor. There's an interesting factorization here, but that's not the point. So, 2 more. The product, f times g of x. What is that? Well, let's take, here's f of x. Let's take f of x. Oh, what's going on here? Let's take f of x, 2x squared minus x minus 6. And let's multiply it by g of x. So I'm going to go a little bit quicker here. Let me first insert some space. Here we go. All right. How am I going to go quicker? You have to be careful, okay, if you move quickly. Don't make mistakes. I do know I have a tendency to make mistakes. So let's get the x cubed. They're only coming from this product right here. 2x squared times negative x, that's negative 2x cubed. Got my x cubed. Let's grab the x squared. Where are they coming from? They're coming from this product here and this product here. So how many do you have? You have plus 4, and then negative x times negative x is plus x squared. So plus 4 plus 1 plus 5x squared. Then what do we have? Then let's get the x's. So x's right here and right there. So that's negative 2. Oops, second one is wrong actually. It's got to be a bit longer. Right here and right there. So we have negative 2 plus 6. Negative 2 plus 6 is plus 4 plus 4x. And finally the constant is negative 12. Here we go. All right, last operation. Last operation is the ratio of the two functions. So again, write the definition. It's just the ratio of their outputs. So f is this one, minus x minus 6, and g is 2 minus x. Okay, so what is f of x over g of x? Well, this is it. But you know you have to simplify, but you got to be careful when you simplify. This is a function. I'm not interested in domain here, but if I were, I would have to be very careful that before I simplify, if I can't simplify, I would have to say that x cannot be equal to 2. No matter what happens at the end, x cannot be equal to 2, okay? Let's try to factor this and simplify. So let me try 2x, 6, let's try with 2 and 3, and I want a plus 1. So if you put the 2 there, you're going to have a 4 and a 3. You can make a 1 with that. I want minus 1, so negative 4 and then plus 3. And yep, it works. So over 2 minus x. So now I can simplify actually, but you got to be careful. You have x minus 2, and here you have 2 minus x. They're not the same. They're called opposites. What happens when you simplify, when you have a ratio of two opposites, like 5 over negative 5? What do you find? You find negative 1. So when you simplify this, you're going to have a negative 1. Therefore, the answer is negative 2x minus 3. Okay? And you see, if I were to think of domain here, I would have no idea why. Just looking at that, you would have to move 2 from it, because this is okay at 2, right? There's no problem at 2. But actually there is one, because this function is defined as a ratio of two functions. So it can't, the denominator cannot be equal to 0, okay? Let's continue. I'm not going to go over this example here. We'll do it in class. maybe insert with a bit of space, but we'll do this example in class number 2. So let's go over this table. You have to get used to looking at functions like that numerically in calculus. There are many examples where we illustrate what's going on with a table like that. I'll do 2 problems here. I'll do the sum and I'll do the ratio, okay? So what is the sum of f and g at -3? Well, you know what it does. You have to add the outputs. So it is f of -3 plus g of -3. Okay, when the input is -3, what is the output? Well, the output of f is 2, and the output of g is also 2. So 2 plus 2 equals 4. Okay, that's it. This is f plus g at -3. So you just read the table, and these are the inputs, and this is the output of f, and this column represents the output of g. Okay, we do not know any other value for f and g, and that's okay. Let's do the ratio. So by definition, you have to take the ratio of f of -4 and g of -4. So what is f of -4? 3. What is g of -4? 0. Uh-oh, this is just undefined, and that's okay too. That means what? It means that -4 is not in the domain of f over g. You cannot do it. You cannot divide by zeros. That means it's not in the domain. Okay, I don't want to focus on domains, but I can just say something when I see a problem with a domain. Okay, here's the other operation I've talked to you about. So for this, there's a nice diagram in the notes. Let's quickly check out what's going on here. I'm looking at the function. I'm thinking of a function as something that carries element from one set to another set. So the first function right here would be f. This belongs to there's a set right here, I don't know, this is like, let's say it's A. This is a domain of f, and here's another set, and this is the range of f. So f goes from A to B, okay? Now suppose when you land in that set right here, suppose that you have another function that is defined from this set and that goes into another set. And this function, I'm going to call it g. Then you can go further. You don't have to stop here. You can go further into the other set. How do you do that? Well, this now becomes the input of g, right? And you put that in the g function. And so you have g of f of x. How do we represent this function? So this is a very important concept actually, in calculus especially. You go directly from, well, I didn't give a name to this set, let's call it C. You go directly from A to C, and the function is called, so it's called f composed with g. This is not red fog, okay? This is f composed with g, okay? This is the 5th type of algebra of functions I told you we were going to cover. Let's go over some examples again. This is a review from last year. I'm just going to go over one example, and we'll finish the rest of the examples in class tomorrow. Let's go over the first example right here. Okay, so what do we do here? We want g composed with f and f composed with g. This is not goth and this is not fog, please. Okay, so let's start with g composed with f. What do you do? Well, let's write the definition. What does it mean? It means that f is the input of g. So here the input is not x, but it's f of x. All right, well, what does g do? G is a very simple function. G just does 2 minus x. So 2 minus the input. So here it's going to be 2 minus the input, f of x. That's it. And 2 minus f of x, so it is 2 minus 2x squared minus x minus 6. So it is 2 minus 2x squared plus x plus 6. Let's order everything here. Negative 2x squared plus x plus 8. That's it, okay? Let's try to find the expression for the other composition. This is f composed with g at x. So what's going on? The input of f is now g of x. Well, what does f do? Well, f is a little bit more complicated than g, okay? This is what happens to the input. So here the input is g of x, so you got to square it, g of x squared, and then minus the input again, right here, and then minus 6. Okay, so at this point, let's replace the input by the expression that we have for g of x. So it is 2 times 2 minus x squared minus 2 minus x minus 6. Okay, a little bit more space. And let's finish this question. All right, I'm going to go directly here. I have to be careful. I know I can make mistakes when I do that. Negative x squared is x squared times 2 is 2x squared. 2 minus x, the double product is negative 4x. Negative 4x times 2 is negative 8x. And then 2 squared is 4 times 2 is 8. Minus 2 plus x minus 6. Hey, if I went too fast here, just take it on the side, take it slower, but everybody should be able to do this this operation here, okay? So this is 2x squared. Where are the x's? Minus 8 plus 1, negative 7x. And the constant term, plus 8 and, oh, minus 8, there's no constant term. That's it. This is the expression for f of g of x. Something we notice here is that, and this is the expression for g composed with f of x right here. Something we notice is that they are completely different, and something we do when we do some abstract algebra, this composition law is not commutative. Okay, that's how we say it. If you check out the definition for the addition is commutative. So is the multiplication. The multiplication is also commutative. This composition is not commutative. Anyway, we'll finish the other example tomorrow in class, and this will finish the second video.